Good morning. We're going to talk about the Weed Seed Wizard today. My name's Alex Douglas and I am a research scientist with DPIRD based in Vitanning. And also with me is Catherine Borger. Well, say hello, Catherine.
Hi, I'm I'm the lead of the Weed Science Unit at Department of Primary Industries and Regional Management based at Northam. And this talk is because Alex and I have both been working hard to update the Weed Seed Wizard. This model's been around for quite a long time, but we've made quite a few changes to it. And it's a valuable model that farmers and agronomists and researchers will find it useful. So we thought we'd run through and show you what you can do with it.
Right. Yeah. Okay, well, let's carry on.
The information that we put in our updated model came from two main projects. The first is a GRDC funded national project, which was called Seed Bank Ecology of Emerging Weeds. This project was led by Professor Gurjit Gill out of the University of Adelaide in South Australia. It also involved ourselves at DPIRD, Professor Bhagarath Chanan at the University of Queensland, and also had Hanwen Wu at New South Wales DPI at the start of the project. This project looked at 24 different weed species. Each of these national groups had about 10 weed species to look at, but we didn't end up with 30 or 40 weeds because a lot of the weeds were copied. For example, we looked at button grass in WA and Bhagarath looked at button grass in Queensland. So we had a really good idea of what button grass is doing in some very different climates and habitats. All of the information from this 5-year project has ended up in an online book, Ecology of Major Emerging Weeds, which is on the GRDC website. You are welcome to search it and download it. It's a free publication. This book goes through each individual weed species, starting with Afghan melon. For each weed species, we have some key points. We give a bit of a background and a description. Why is it a weed? Then there's detailed research findings on the seed bank ecology, including dormancy, seed bank persistence, seed production and dispersal. And we have a look at the competition with these weeds with various crops.
Right, and my project, Locally Important Weeds, was also a GRDC national project, which I led from DPIRD, but we had collaborators in South Australia, Gurjit Gill, who also did work through to the bottom of Victoria as well, so it was the southern region. And there was a collaboration also with Rick Llewellyn at CSIRO in Adelaide. They're looking at developing a model on summer weed management. So there were quite a few facets to the project. Like I said, it was also a 5-year project. We only had 8 weed species. So we had Matricaria, marshmallow, feathertop Rhodes grass and stinking love grass or stink grass in the western region. And Gurjit looked at caltrop, common vetch, Lake Boga poppy, which is an obscure, very small weed in Victoria, and Lincoln weed in the southern region. So some of these weeds had also been done by the project that Catherine was talking about. So this was a slight bit of overlap, but we ended up, so go on to the next slide, please, Catherine. So we did a lot of the same sort of ecological studies that Catherine did in her project, but we also looked at some management options because a lot of these weeds don't really have anything on herbicide labels. So we had a few herbicide controls we tested. So for example, we looked at Matricaria, which is a weed that's spreading through the central wheat belt and into the northern regions in WA. And we found that it can be controlled reasonably easily in subclimatic pastures, particularly using bromoxynil. caltrop, summer weed, well controlled with glyphosate. The problem is it's getting the glyphosate at the right time. So when the plants aren't stressed through heat or drought, and then you're using a proper rate. So herbicide failures have been partly because of the environmental conditions. And one of the other weeds we looked at was vetch, which is quite a serious grain contaminant in lentils in the southern areas of South Australia. And Gurjeet's team found that if you use pre-emergent herbicides with an IMI herbicide like Intervix, that was very effective in preventing crop loss, but not as much on contamination of the lentil grains. You still reduce the amount, you still had some carrying into the grain. So there's a bit of further work we'll probably need to do on there as well. Right. Okay. And like Catherine's work, the biological information we used to sort of update the Weed Seed Wizard. So Catherine, if you want to carry on with this part of it.
Sure. The Weed Seed Wizard is a free model. Anyone can search Weed Seed Wizard, which is really easy because there aren't any other Weed Seed Wizards out there in the world. You won't get a confusing list of alternative products in your search. So you can just go to our DPIRD website and download it, which is pretty quick and easy. The model itself is a decision support tool. It gives a computer simulation of how the long-term weed population dynamics interact with the environment and with different management strategies. It's applicable to Western, Southern and Northern regions of WA, all the major GRDC zones. The types of decisions you can put into the model, you can specify your soil type and your weather. You can look at tillage, soil renovation. That certainly has a big impact on weed ecology and weed seed placement. Obviously, there are different crop sowing options, knife points versus disc seeding. Obviously, there are a lot of herbicides in the model, and you can add some of your own. You can look at pasture and grazing, irrigation events, not a big issue for us here in the West, but lots of people like to irrigate their crops, and different harvest types and harvest weed seed control options. The real strength of the model is that you can use it for individual fields. If a grower has good rainfall records, and obviously they're going to have agronomic records of what was done in that field, you can recreate that exactly in the model and have a look at exactly what was going on in that field, what could have been done differently. Although you have to be a little bit careful with rainfall records. I had a summer trial at Wongan Hills, I think it was back in 2016. Was that the year that we got heaps and heaps of summer rain, Alex? And there was flooding all over the state?
Yes, it was 2016 into the early parts of 2017. So we had quite a lot of rain.
Yes, I was desperately trying to grow Afghan melon and caltrop in Wongan Hills, and the Wongan Hills weather stations showed that I got 60 to 120 mils of rain, but about 1.5 kilometres away from the weather station where my trial was, I actually got 8 mils of rain in that paddock. It wasn't even a whole 8 mils, Alex. It was like 2 mils in 4 different increments with really hot days afterwards, and it just dried up. And there I was at various research updates going, well, I had maybe 2 small weeds per metre squared. And everyone was going, it flooded, Catherine, it flooded everywhere. How can you be that bad at growing weeds? So rainfall can be quite variable. But if you know your rainfall, then you can link exactly what happens into the model with what happened in the field. The other strength is that you can have a really wide range of weed control options. As we discussed, you can put in soil renovation and a range of options that aren't commonly available in the other models. And you can look at multiple weed species. You never just have one weed in your system. In this model, you can have 6 or 8 weeds growing in your crop if you really want to.
Yes, it's a lot more realistic because you can have nice rotation set up, how you like it, and then you can have the weeds that you have as you know them. And yes, Catherine said, you can introduce your own weather as well. So you can tailor it for your area quite well.
And also you can change any parameter in the model. And I know what you're thinking, I'm not a computer IT person, I can't start modeling, but trust me, Alex and I aren't expert IT computer modeling people. We are weed ecologists. This model was created by some very competent, clever weed and computer experts, mainly Michael Renton at the University of Western Australia. And it's been really well designed, so somebody who knows nothing about computers can easily update it. For example, if you have a brand new weed that's not in the model, you might look at the list of weed species and go, oh, it would be really hard to add a new species. But when you think about it, most weeds act the same way. You have, I don't know, a broadleaf winterweed. It probably germinates at seeding time. It grows until you spray it or until it gets a bit hot in summer and then it dies. So if you had a brand new broadleaf weed, you could just go, well, it's a bit like wild radish, isn't it? So you could just go into the model and make a duplicate of wild radish and then give it a new name, depending what your new species is. And then go, I don't know heaps about my new species. Maybe I know optimal germination temperature. That information is usually available in the literature, or total weed seed production. So just take those two numbers that you do have, pop them in the model, and then you've got a new weed species. Okay, your new weed species is going to act a lot like wild radish because that's what you based it on. But again, most weed species act like the other weed species.
Yes.
It's particularly, sorry.
I was agreeing with you. Yes, they do. And it's only killing them. So finding the correct way to manage them in your situation is often what's the hard part. It's not making them germinate when you don't want them to. It's sort of like that. So, yeah, so those sorts of things, it's quite easy to make it your own model.
Yes, and adding a new herbicide or updating the herbicides you have is particularly useful. I mean, we all know you can't spray an entire farm on the perfect day in the perfect weather conditions. So if you think you're, say, spraying an existing herbicide in poor weather conditions at the wrong growth stage, you can just change its efficiency to 80%, or you can add a brand new product. These are the weeds we have added or updated to the model. You see quite a lot of them were in Alex's project.
Yes, so but we did already have a start on feathertop Rhodes grass, because this model, we haven't mentioned it, but it does actually cover the 3 grain growing regions in Australia. So the southern, western and northern regions, so up into the southern Queensland, northern New South Wales area, where feathertop Rhodes grass is quite a common summer weed in crops. So we have been able to make it work a bit better, with a bit more understanding on how it goes. So the information has made the model work better for these weeds.
Okay, should we swap over and have a look at the model?
I think that's a good idea. Let's show people how easy it is to work.
Here's the weed seed wizard. I'm just going to have to move that for a second. I've opened it this morning. So the first thing you do when you open it is open a scenario. You can spend half an hour creating a scenario that matches exactly what happens in your field, but you can just open one of these existing scenarios where everything's put in for you. This is particularly useful if you just want to discuss something generic like harvest weed seed control. You can really look at that using any scenario. So the first thing we should look at is scenario setup. You need to put in a time frame. This rotation is looking at crops from 2005 to 2008. And if somebody's going to ring me up and say, I tried using your model and it's not working, my scenario is doing weird things, 80% of the time, what happened is the scenario time frame was too short. You can see this scenario starts on the 11th of November in 2004, even though it's for the 2005 cropping system. That's because you plant the crop in 2005, but you planted the weeds in 2004. Weeds like ryegrass get planted when you harvest the crop. You knock all the seed heads off and you either use some kind of harvest weed seed destruction or you spread them back on the ground. But either way, the ryegrass was dropping its seeds at the end of the season. And then those seeds sit there over summer. Some of them degrade, they have after ripening, they lose dormancy. And because the model is taking all of those things into account, it really needs the seeds to be planted the summer before you're going to start cropping. So this date, 11th of November, 2004, it's a little bit arbitrary. You just need a date somewhere in November, December, October, just before you're going to plant the crop. And again, this scenario ends in the 2008 cropping system. And the model time frame ends on the 1st of January in 2009. Because another query I get is, it's not showing my harvest yield in 2008. Well, if you end the model on your harvest day in 2008, it can't generate that data. So it's best to end your scenario time frame a little bit after your final harvest. Here's the seed bank. These are the species that's in this default scenario. We have ryegrass and radish. You can add more weed species if you're interested. We have a soil type. You can choose a different one if you'd like. This says, this is a weather record. It says the file is not found. I don't know why it's been doing that when I open the model. It wouldn't actually affect the scenario or the way we used it. But I might change the weather. I put all the weather files on my desktop because otherwise I keep losing them if they're buried in the C drive.
And you can see from that there are a lot of weather sites with weather going back in a lot of cases 100 years if you want to get excited about it. So up until current year as well.
Yes, that's a good point. I'm going to pick Meriden weather because I spent a lot of time in Meriden. I still miss it a bit. So I know what the crops and weeds are meant to be doing in Meriden. Event management shows us all the different events. So for example, on the 15th of April, somebody sprayed glyphosate and Logran. And then...
So Catherine, we've just had a question from Cindy, just wanting to know about the, do users need to download the rainfall and save on their computer to insert? So if they want to do their own rainfall.
Right, well, once you download the model, it will come with the weather files and you can decide where you put it. I would just quickly open some weather files and show you one. Let's go with New South Wales, Griffith. If you open up the weather file, you'll find that it's a very, very simple file. We have weather data retrieved for the Wheat Seed Wizard on this date. So that's when it was downloaded. And then you have each date. This starts in 1920. You have rain, maximum temperature, minimum temperature, and evaporation. So that's a type of pretty basic data you can get from any weather station. There's really no reason to start in 1920. You're not likely to be looking at crop rotations in 1920, so I don't know why it fishes out weather from 1920. If you were using records from a farm, you might just have rainfall. So maybe you'd open the existing weather station closest to that farm and just put in the date and then the rainfall amount on each individual day. And again, you don't need from 1920 to 2020. You can delete all of this if you want to, and just put in the dates for the 3 or 4 years you actually want to look at your crop. So you might use existing temperature and evaporation and just put in your own rainfall, because rainfall is going to be the biggest influencing factor on when and where seeds grow. But the grower might also have temperature, or there might be a nearby weather station that you can use. There's lots and lots of sites on the internet, including BOM, where you can download your own weather data. It's not secret hidden information. So yes, just drop in rainfall data, maximum and minimum temperature for each day, and evaporation.
Yeah.
And then you can put this file in. I'll save that.
So yes, you save any changes or new files to the folder where you've saved your other weather data in a CSV format. And then on the front page, when you go into weather, you can then choose the weather in the way
Yes,
we showed you earlier. So, you just have to move your information and put it in the same format, so the CSV file, in the same spot where you've got all the other files, so you can find it easily, and then you can do what you like with it.
yes. You can have these files saved wherever you like, but if you're making a new weather file, it will be easiest to just open one of these, rename it for your site, and then adjust some of the data and save it here. Because if you're modifying a file that's already there, you know that the format's right and it is in that CSV file format. I have to admit, I don't know if it would work if you just uploaded an Excel file. I've never tried that. It might.
Well, let's save that for another day. Okay, so we were talking about the event management.
So this just has your different events. You can change any of these events if you want to. You could say, I sprayed glyphosate back here on the 15th of April in 2005. But it was a terrible day and the weeds were too old and it just didn't work and it didn't control the barley grass. So I only got a 30% kill rate. And if we had barley grass in this model, it would then only control 30% of it. So those are the types of little changes you can make just based on your knowledge of that particular site and what's going on. Once you have your scenario, you can run a simulation. Here are the results from that simulation. So if we start with harvest, the red bar is what your yield was. The blue bar is the amount of yield you lost from weed competition. Over here we have the plants. This red line is barley crop. You can see a barley crop gets sown and then grows and then gets harvested on a certain date. The model doesn't assume the barley dies during the year. You could spray a herbicide and make all the barley die during the year, but the model assumes as a base that your crop manages to stay alive. So this yellow is your wheat, and we also have lupins in this rotation. Green down here is your ryegrass plants, and pink is your wild radish. So you can see in this scenario, wild radish is at 20 plants per metre squared at the start of 2005 in April. And then they get sprayed each year and they're pretty much under control in the crop, but there's a little bit of ryegrass surviving in the crop. If you like, you can click on display event markers. And that gives you an idea of each event when it happened. So obviously this grey dotted line indicates that seeding and spraying that happened early in the year. This grey dotted line indicates crop harvest. And these extra dotted lines indicate when the herbicide went on. If you want to zoom in on this figure, you just click with your mouse and drag a little box across like that. So you can see you had 20 wild radish plants, you sprayed some herbicide, and then they went down to 1 wild radish. So that was a pretty successful herbicide. And to zoom out, you again click the mouse and drag your little box backwards. For any of this data, if you're really interested, possibly if you're a researcher, you can go to a table view. So then you'll know exactly how many ryegrass plants there were. Obviously, ryegrass wasn't growing over summer. Ryegrass started germinating when it got a bit colder, in March or April.
Quite a lot of decimal places.
Yes, that's probably a bit of a design flaw. Well, we'll ignore that for now. We can't really fix it.
It is important to know where the decimal point is, though. So don't be overwhelmed by the numbers. Look at where the dot is.
Yes, that's a good point. We only have 1.5 ryegrass plants growing in March because it's still a bit hot for them. And of course, you can export your data to save as a file and do what you like with once it's in a different format. This tab shows you the seeds in the soil seed bank. At the start of the scenario, there were 200 ryegrass and 100 wild radish in the seed bank. And this seed bank degrades during the year because these seeds might be degrading, but also some of them are germinating. You can see lots germinate here at the start of the year, so the seeds aren't in the seed bank. But then you get to harvest and you get a lot more seeds in the seed bank. You can see in this year here, at the end of 2005, it was a normal harvest, all chaff spread, normal harvest. So all the weed seeds were going back onto the soil surface. So we also have weather results. You can see what rain, evaporation, temperature we're doing, soil results, degree days after ripening. To be honest, 99% of the time we can ignore those tabs. If you're a researcher and interested in that data, you can have a look. But I'm a researcher and I'm very rarely interested in that data, to be honest, Alex.
Yes, that's right. Well, why don't we have a look at changing something? So what about if we change that, like you said, this one, we had a normal standard, well, current standard harvest of all the chaff being spread. So what if we actually used a seed destructor in every event or chaff cart? So some sort of harvest weed seed management every harvest rather than just in 1 or 2.
Okay, good plan, Alex. I will change each of these to chaff cart. They have a seed destructor there, but I think it would be easier if we kept it consistent to the chaff cart.
So it's very easy. You just sort of double click on the event you want to change, and then you get a box where you can manage the menu. So you can change things in there if you want to. So if all the seed is dropped before you get there, this is not what we're going to look at, but we're looking at comparing if we're collecting everything that's available to collect.
Yeah, that's a good point. Each of these harvest events I'm opening gives you all the harvest details, the date, the crop you're harvesting. That's important. Mm-hmm. I think that's our second most common error. Somebody says, I didn't get any data because they sowed lupins and decided to harvest wheat. That really confuses the model. So if you sow lupins, make sure the crop you harvest is also lupins. That makes it much easier. You can use your actual yield, or you can force the model to estimate a yield for you. Once you choose harvest type, it will give you the number of weeds dropped, Incidentally, if you don't know what any of these numbers mean, they all come with this little question mark next to them. So weed seeds dropped %. If you click on the question mark, enter the seed drops of all species except for the crop. So when we have a chaff cart, we assume that 20% of the seeds have already shed before harvest. If you're curious about something like grape brome, which might have shed a whole lot more seed, you can change any of these numbers. Let's say barley grass shed 80% of its seeds. Obviously, this scenario doesn't have barley grass in it, so changing those numbers won't make any difference. Now, when you're doing a comparison, the easiest way is to open a second scenario. See, I now have unsaved scenario 1, where I've gone to chaff cart every year, and unsaved scenario 2. And I'm going to put this one on normal harvest. Because otherwise you spend a lot of time changing parameters back and forth and you get a bit confused about what actually changed. Now we have our 2 scenarios, one with normal harvest. I will click on this green arrow to run that. Another one with chaff cart used every year, we'll run that. Then we'll go and look at the simulation. Oh, I've broken it. No, it's okay. It just needs thinking time. The first thing you'll notice is we now have 2 different scenarios displayed in the harvest yield section. Unsaved scenario 1 here on the left. You'll see the red yield is pretty close to maximum. We're not losing much of that yield from weed competition. And unsaved scenario 2, where we just had a normal harvest, you'll suddenly see that by the 4th year, we're losing quite a lot of that yield to weed competition. If we go over to plants, we can't see both scenarios side by side, which is not really a surprise. This is a big, complicated graph, so it would get a bit complex if you had 2 of them next to each other. But we can look at unsaved scenario with a chaff cart used, and you'll see that it's working. There aren't many weeds down here. We have in that last year 1.8, so almost 2 ryegrass per metre squared in our wheat crop, and virtually no wild radish. If we click on unsaved scenario 2, you can see we have a lot more weeds in this last year. In that final wheat crop, we have 96, almost 97 ryegrass plants per metre squared. That's probably more ryegrass than you want. The radish is still under control. The herbicides are keeping the radish down. Seeds are the same. We'll look at the scenario with normal harvest first, and you can see the number of ryegrass in the soil seed bank just increases at every harvest event. More seeds are being dropped until you have 3,600 seeds per metre squared. In our unsafe scenario where we're using a chaff cart, the ryegrass seeds just keep going down. They started at 200 seeds per metre squared, and they just go down each year until you only have 20 ryegrass seeds per metre squared. So that management option worked, Alex. We're making some progress.
Yes, yeah, it's nice to see it in a solid line there.
Yeah. We can go up here to model. That gives you edit species, edit herbicide, edit soil tillage type, and soil types. And incidentally, if again you're not feeling like a IT computer whiz and you're worried that you'll do something wrong, it really doesn't matter. If you love the changes you've made, you can save your parameter set and put it somewhere else on your computer. If you're worried that you've done something terrible, you can just go reset parameters. and the model will go back to where it was. If you think you've done something more drastic, you can just download it again from the internet. But you really can't break it. Nothing can go wrong with a bit of playing around. So if you go to edit species, again, you can add a species, but if you're interested in seeing something new, it's easier to just click on something that's already there, like double G, and then just click duplicate. Then you got copy of double G. Then you can edit it, call it anything you like. New double G.
So you could do something like this if you've discovered that you've got a resistant weed. So you can compare a resistant with a susceptible version of the same species, couldn't you?
Yes, that would be a really good idea. But if we go to edit herbicides, you can see there's a list of herbicides here, but we really don't cover all the herbicides. There's a lot of herbicides out there. It's very, very easy to add a new herbicide. You just click on add, new spray type. We could call it super awesome herbicide. Now you can go down here through each of these numbers to say how much the weed will be killed by any individual herbicide, or you can just set some general kill rates. Let's say this herbicide kills 99% of all broadleaves and 99% of all grasses. And let's say it has a residual kill rate of 80. Again, if you're not sure what that means, just click on the arrow. That is the proportion of new seedlings that will be killed upon germinating. So look, we'll kill 80% of the weed seeds coming up. And then it will automatically put these numbers in. Look, 80% residual kill rate, 99% initial kill rate. So if we had kept new double G in this list, then we would have double G and new double G. And we could change that initial kill rate to 20% if we thought new double G had really bad resistance problem. You will notice that after it automatically fills in these numbers, the crop is blank. And I imagine if we had super awesome herbicide killing 99% of broadleaf and grass weeds, we would also kill 99% of the crop. So realistically, this would probably also be 99%. But again, you can put those numbers in and set them to wherever you like. It doesn't make me restart if I make a new herbicide. So now my parameters permanently have super awesome herbicide to select whenever I need a herbicide. It's pretty similar for all of these parameter types. If you want to do a soil renovation and you think my soil renovation is a bit like full inversion using a moldboard, but it doesn't vary quite as many of the weed seeds, you can just duplicate that full inversion, copy of full inversion, and then this matrix just shows you how many of the weed seeds are buried. So the weed seeds started on the soil surface. Then with a full inversion, most of them get buried to 10 to 20 centimeters, but some of them are going to be left in that 0 to 1 centimeter or 1 to 5 centimeter. You can change those numbers to whatever you think reflects your system.
Okay, so how about if we look at a summer weed? Because, you know, most of the scenarios that we look at are actually, you know, a cropping year and we're doing things to the weeds that are coming up with the crop. But particularly in Western Australia, we don't usually have summer crops. So what happens if we want to introduce a summer weed to our paddock?
That's a good question, Alex. I'm going to open some new scenarios because I'll be honest, this model gets a bit confused if you run too many scenarios at a time. And we've been playing with it for a while now. So we keep running scenarios indefinitely, we're going to start getting errors. That's not really the model's fault. You have to remember that this model is generating a huge amount of data in the background. It's tracking every single weed species over multiple years, looking at whether it degrades, how it after ripens, how it responds to every event.
Yeah. So that, how does that look like? It, it won't let you do anything and essentially just sort of freezes certain areas?
Yes, it has been known to freeze. If it freezes and it's doing weird things, just turn it off and restart it.
Yeah, because you've got the option to save as well. So you don't lose what you've been working on. So you can save things. And that's probably a good habit to get into, save some things. Okay, so you're adding caltrop to both of our scenarios. And
so I've
one. Is one enough?
Well, let's see what it does. I've just opened 2 new scenarios, again from WA. I've added 1 caltrop seed per metre squared to each of them. Let's see what our simulation does. Well, that's not exactly what we wanted our simulation to do.
No, that's better. That's not.
Okay, our harvest looks the same because our 2 scenarios are exactly the same. How do our plants look?
Okay, so the caltrop is the blue one now. So the blue line is the caltrop.
Right. So, Alex, your husband's a farmer. Would you say this caltrop was a problem after 1 seed per metre squared?
Yes. So I think if we don't do anything about it, it could very easily become out of control.
Yes. There really wasn't much happening in this first year. Let's zoom in. Did anything come up that summer? These are blue caltrop plants.
Like half a one.
Half a caltrop per metre squared. And from that, you have to remember that this scenario has no summer weed control.
Yep.
Yes. After 4 years, we had over 1,000 caltrop plants per metre squared. So summer weed control is a good idea.
Yes, definitely. And you can see also, particularly in the January 2007 area, all the little rainfall events causing germination of the caltrop over the summertime as well. So you can actually pick up when the caltrop is coming up and work out, oh, we should have done one as soon as we saw it in December, in the new year. But then definitely do something else, another lot of control. So you can see that you should have probably done 2 controls because you're getting more than 1 germination following the different rainfall pattern.
Yes, that's a good point. And another real strength of this model is because it's taking the exact temperature requirements and moisture requirements of the weed into account when it looks at germination. You'll see that in this particular year, the caltrop has come out in October and November. And I'm not sure exactly what you do about that. There are logistical problems with controlling caltrop when the crop is still standing. We possibly need more research into residual caltrop control in crop. But you can see some years, there might just be a spike of germination in spring. Some years there's no real germination in spring. Some years there's lots of germination in spring. So it's really looking at the environmental conditions in each year and how the weed would respond to that. Should we try some caltrop control?
Yes, let's try something. Let's do maybe just one glyphosate. When would be a good time to add that one in?
Well, let's look at our simulation. We could add a glyphosate around here. That was quite a big cohort.
Yep. So the early February.
Yep. Early February would be good.
Yep.
Maybe the 10th.
Yep, let's go with the 10th.
Okay, let's spray a herbicide. 10th of February. Sorry, what year was that, Alex?
2007, I think. Let's
Okay.
see.
Spray type, glyphosate.
Yes, glyphosate.
Sorry, what am I doing? Well, glyphosate isn't that effective against broadleaf weeds. How about we add a bit of 2,4-D into the mix? And this shows you how much of each weed you'll control. Okay, here's our new spray event. We'll just run the scenario again. Okay, well, we spray. We can see that weeds went down, but later on in the season, we still have over 1,000 plants per metre squared. We probably need more than one summer spray over 4 years to control caltrop. Do you think we should try a soil inversion?
Yes, why not? When will we do that? Do we do that in March? Or do we have to wait for rainfall?
Oh, hang on, what am I doing? I wanted tillage type. I don't know. I have to admit, I'm not a soil renovation expert. We can assume the soil was pretty wet because there was a lot of caltrop growing then, so
yeah,
there must be reasonable rainfall.
So this is just for a research purpose anyway. So if you're doing correct timings, it may not work.
Yes.
Like this, but this is us playing.
Yes, we are weed ecologists. We are not experts on soil renovation. Talk to someone else if you're looking at the best time of year to renovate. Okay, we've gone from over 1,000 caltrop plants to 400, and we buried them all. We still had some coming up after our soil renovation, and that's probably fairly accurate, Alex. It's what we've seen in the field this last couple of years with Sultan Mears project. Soil renovation, we think a full inversion goes down to 30 or 40 centimetres, but the weed seeds are scattered from 5 to 20 centimetres. And weeds, particularly those species like grape brome or caltrop that have a larger weed seed and have a chance of emerging from depth, there's a fair chance they'll keep coming up after a soil inversion. There'll be a lot less of them. I have seen sites where soil inversion actually stimulated the grape brome grass. They got a bit more grape brome emergence because grape brome loves being buried and it wasn't buried deep enough to prevent emergence. So a full soil inversion is not always enough to solve all your weed problems, particularly if your caltrop is as out of control as our caltrop population was after 3 years of no spraying.
Just as an aside, it's done the trick on the ryegrass and the radish though.
Yes, that's true. It did a great job burying those. They both have a much smaller seed than caltrop. They're easier to bury, and ryegrass in particular doesn't do well coming up from depth. As I said at the start, it's very easy to find. Just go into Google, type in Weed Seed Wizard, and right at the top, you get our webpage with the model itself. Alex has just done a great job revisiting this website and making sure it's completely up to date.
Yes, and it's easy to download the wizard. So as you see, there's a lovely green download the wizard button. And you don't just get the wizard, it comes with the correct versions of Java to make it work. the weather files should also be there as well. Yes, there they are. So you can add in weather files. If in the future we also make changes to parameter sets, so how the weeds work in the model, there is another page in this sort of set of wizard pages where you can actually find updated parameters. So you can see that on the, I'll get my left and right organised shortly, on the left-hand side of this screen. So we've also got wizard case studies. You can see, you know, sort of what we've been doing today, people having a play with various things in the model. Some details on the model itself. There's a download and help section. So this is where extra parameter sets, or if there's a new version of something come in. And that's also going to have, so it tells you how to load your own weather data, how to load the weed parameter set if we make changes to it. If there's any issues with installation, this gives you a bit of an insight into how to change that. And I think the scenarios, so there's also some little how-to videos. I don't know, are they on this page or the next page, Catherine? If you scroll down.
Maybe on the scenarios?
Could be. So these are the ones that come up when you open the wizard and it says, you know, what's your default scenario? So it comes up with these scenarios. So as you can see, there's some targeted for the 3 regions, grain growing regions in WA and South Australia, Victoria, New South Wales, North and South, and Queensland. So you can pick those sorts of things, and it gives you a start on what a reasonable rotation would be, and those sorts of things. So if you're particularly having to play with something in an area you don't normally play with. So yes, there is a lot of information on those pages.
If you have any queries at all, you will see that each of these pages has myself, Alex Douglas, or Sally Peltzer down the bottom for contact information. Let's go back to the Weed Seed Wizard homepage.
Yep. Yeah, so as you know, I mean, we've spent a bit of time today looking at the wizard, what's been improved and what's been added. Lots of species there to look at. You've seen that it's actually quite easy to use and very easy to download. Download is quite quick. It looks like it's very big, but it's actually a very quick download, and it's a lot of information all at once. So Catherine and I are contactable quite easily at DPIRD in either Katanning for myself or Northern for Catherine. And yeah, we encourage you to have a look at the wizard when you get the moment.
Yes, if you're an agronomist or a farmer, it's a great way to explore individual problems. If you're a researcher, it's a great way to extend your field data and look at some of the other alternative things that could have been tried. So this model offers a lot of different management and research options for a lot of different people. And as Alex said, if you have any queries, if you have any really difficult computer problems, we won't help at all. But if you have any basic problems with the model, we'll probably be able to sort them out for you. So have a play. I hope you enjoy using it.